In this example, we're going to find the derivative of a vector-valued function. And so I'd like to remind you that r of t can be given in I, j, k hat notation, or we could be using these angled brackets where our first component is 2t cubed, second component t times e to the t, and the third component cosine of 3t. Now, it's good to take a moment to review rules of differentiation. To find the derivative of r of t, we need to do the derivative component-wise. And so for the first component, this is just our power rule from Calc 1. T times e to the t. Right here, we're going to need our product rule. And over here, we have cosine of 3t, and this is a good example of where we would use a chain rule. So if you feel a little rusty on any of these rules of differentiation, this is a good time to review those rules. So let's proceed with our derivative. R prime of t, derivative of the first component is going to be 6t squared, and again that's with our power rule. Second component, we need to do the derivative of the first, which is 1 times e to the t. So derivative of the first times the regular second, plus the derivative of the second factor, which is e to the t, times the regular first. Third component, we need to use chain rule here. So the derivative of cosine is negative sine 3t. And then doing the derivative of our inner little function, the derivative of 3t is 3. Now we might be tempted to write that 3 on the back end there, but it's probably clearer if we write the 3 before our trig function. So I'll write this as negative 3 sine 3t. Okay, we could clean this up a bit and say that the derivative r prime of t equals 6t squared I plus our second component here is really e to the t, pulling out that as a common factor, times 1 plus t. And that's sitting on the j component. And lastly, we have negative 3 sine 3t k. That's our third component. So that would be our